I'm Anil Kumar. Welcome to my series on input-output pattern rules. We have 5 questions here. We'll answer them one by one. Question number 1. Copy and complete the pattern for each input-output machine. Explain how they are similar and how are they different. So here we have two input-output machines, A and B. We need to compare between them. A is, we are given inputs of 1 to 5. We need to calculate the outputs. Each output in machine A is input times 2 plus 1. For machine B, the output is input plus 1 times 2. So the order of operation is slightly different, right? Let us first find the outputs for machine A. When we say input times 2 plus 1, input is 1. That means 1 times 2 plus 1, right? So 1 times 2 is 2. 2 plus 1 is 3. Then we do 2 times 2 and then we add 1. 2 times 2 is 4. 4 plus 1 is 5. Then we have 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. And then we have 4 times 2 plus 1. That gives us 9. And then we have 5 times 2 plus 1. 5 times 2 is 10 plus 1 is 11. So we get 3, 5, 7, 9, 11. And if this continues, we know the next will be 13. So we do see that the numbers are increasing by 2 or odd numbers. Pattern B. Input plus 1 times 2. So when you send an input of 1, then you add 1 first and then multiply by 2. So 1 plus 1 is 2. 2 times 2 is 4. Next input of 2, add 1 to it and then times it with 2. 3 times 2 is 6. And then we get 3 as an input, multiply by 2 after adding 1, right? So which is 4 times 2 is 8. And then for 4, add 1 times 2. 5 times 2 is 10. 5, add 1 times 2. And we get 5 plus 1 is 6 times 2 is 12. So you have the outputs for the given inputs. Now, second part of the question is how they are similar and how they're different. So as far as similarities go, what can you say? So we see as we go from 1 to 2, we are adding 2, sorry. So in each case, we are adding by 2. So in this case also, we are adding by 2. So that definitely is a similarity, correct? So that is similar. And how are they different? Well, here you see the output is odd numbers. And here the output is even numbers. Do you see how they're different? So you can explain input and output using the rule how they are similar and how they're different, correct? Let's move on and take the next question now. Question number 2 is, write the pattern rule and then find 10th and 100th term. Is the number 63 an output of this pattern? Explain. Now last time input-output rule was given to us. Now we need to figure out this rule. How do we find? So we'll work backwards. That is, we know the output. Let us see how the output changes. So as the input changes by 1 each time, output changes by 7 minus 3 is 4, right? In this case, we have 11 minus 7, which is also 4. And then again, it is 15 minus 11, which is also 4. So what is happening here is that you are adding 4. So if I want to get the 5th number, what should I do? Well, I have to add 4. So once I add 4, I get the next number as 15 plus 4 as 19. Do you see that? Correct? Now from here, you can actually write the pattern rule. So we'll learn two methods of writing pattern rules, right? So let me call first method 1. In method 1, let us see the first number. So when the first number is 3, you're adding 4 to it, right? To get the second term number, right? And then again you add 4. So to reach the third number, you add 4 2 times. You get the idea, right? So you start at 3, basically. And then you add 4 each time. So when you start at 3, you are adding to 3, right? So you can say this number is just 3, right? The next number is 3 plus 4, and 11 is 3 plus 4 plus 4, and then 15 is 3 plus 4 plus 4 plus 4, and then next you add one more 4 to it, correct? And likewise, it moves on. So what you notice here is that when the input is 2, you add 1 4. When the input is 3, you add 2 4s, right? So you add 4, 1 less than the number required. So if it is writing a general term, let's say, if I write 10 here, how many 4s will you add? Well, you are going to add 9 4s, 1 less than the term number. So here the number should be 3 plus 9 times 4, correct? Similarly, if I want the 100th number, then I should add 99 4s, right? So I should add 99 times 4 to get my number. So using this rule, which is start at 3, add 4 each time, what we notice here is that you start at 3, and to get the nth number, we add n minus 1 times 4, right? So many 4s we add. So that is one way we can figure out. Now let's talk about method 2. Now I prefer this method 2, which is straightforward. And that is, we know that by adding 4 we got the result. We are increasing by 4 each time. So what we do here is that we check our result with the very first number. What is 1 times 4? 1 times 4 is 4. How do I get 3? Take away 1. So what I notice here is that 1 times 4 is equal to 4. Now to get 3, I should do minus 1 to get 3, correct? For 2, it is 2 times 4, which is 8. And then again I do minus 1 to get 7. For 3, I do 3 times 4, and then I get 12. And when I take away 1, I get 11. Do you see that part? That means for 10, what should I do? 10 times 4, and then take away 1. So 10 times 4 is 40, and take away 1 is 39. That should be my result. For 100, 100 times 4 will be 400, right? And when you take away 1, I get 399 as my answer. You get the idea. So basically, I have a rule here now. The rule is like this, that I have an input, and the machine which I have is multiplying each number first by 4. I'm saying times 4, and then take away 1. So that is the operation to get the output. You see that? So times 4 and then take away 1 becomes the rule. Perfect. So using this rule, we have found the 10th and the 100th number. So the 10th number will be 39, 100th number will be 399, which you can also find with the first method. Now, another part of this question is the number 63 an output of this pattern? So what do we see? All the numbers are 1 less than multiples of 4, right? Correct. So we need to see, is 64 a multiple of 4? Well, 64 minus 1 is 63, and 64 happens to be a multiple of 4, right? So 64 is a multiple of 4. And so 63 will be there. Can you tell me the term number? Dividing 64 by 4, we get what? 16, right? So this will be our 16th term. So 16th number will be 63. So you can check. 16 times 4 minus 1. 16 times 4 is 64. Minus 1 is 63. Do you see that? So we get 63 is a part of our pattern, right? So the answer is yes. And the explanation is, since 63 is 1 less than 4 multiple, it has to be an output. And it is going to be the output for which number? 16 input, right? The 16th term. Let's take the next question, which is question number 3. It says, write the pattern rule and then find 10th and 100th term. Is the number 30 an output in this pattern? Well, this is very similar to the last problem. You can use the pattern rules, whichever you find convenient, method 1 or 2, and then figure it out. I like method 2, right? So what I will do here is again check by how much are we increasing each time. So 8 minus 5 is 3. So we are increasing by 3, right? So when we add 3, 11 minus 8 is also 3, and 14 minus 11 is also 3. So what we are doing here is we are start at 5, and then we are doing add 3 each time, correct? So that is the pattern rule. Now, how do I define this as a machine operation? Well, what we are doing here is that to each input, we are first multiplying that input by the number 3, right? So if I have an input here, let's say input, and then what happens is we multiply it by 3, and then what do? 1 times 3 is 3, right? So 1 times 3 is 3. To get 5, I have to add 2 to get 5, correct? So what we do next is we add 2. So in this machine, we have the operation times 3 plus 2. And then we get our output. Do you see that? So that becomes our pattern rule. Now in this case, for the 10th pattern, if I input 10, I will get the number 10 times 3, which is 30. And to 30, if I have to add 2, I get output as 32. Do you get the idea, right? So for the 10th number, the operations will be times 3, we get 30, plus 2. 32 will be the output. Similarly, for the 100th number, what we will do? We'll get 100 times 3, and then, which is 300. To 300, we are going to add 2. And so we get 302 as our output. Do you see that? So we can work like this also. This is another method of working, correct? So we have this input-output rule times 3 plus 2. Now the next question for us is the number 30 an output of this pattern? So what do you notice? Every number here is, you cannot say otherwise, 1 less than a multiple of 3. 2 more than a multiple of 3 is same as 1 less than multiple of 3. 30 is a multiple of 3, which is not in our output, right? So we'll write, is the number 30 an output of this pattern? The answer is no, since multiple of 3 is not the output. What are you doing? You're adding 2 to it. 2 more than the multiple of 3 is an output, correct? Not the multiple of 3. So that is why 30 is not a part of our output. Is that clear? Now with this in mind, I would like you to answer question number 4. Question number 4 here is, an input-output machine follows these steps. Divide by 7, then add 3. check the data and identify incorrect output. So here we have two operations, right? So in this case, the operations are whatever is the input, to get the output, what are we doing? We are first dividing by 7 and then we add 3 to get the output, right? So 7 divided by 7 is 1 and 1 plus 3 is 4. So this is correct. So we have 7 divided by 7, which is 1, and then we are adding 3 to it, so we get 4. So that is correct. For 14 divided by 7 is 2, and when you add 3, we do get 5, correct. 28 divided by 7 is 4, but when you add 3, you get 7, that is correct. 42 divided by 7 is 6, plus 3 is 9, so this is not correct. Is that correct? So that one is not correct. It should have been 9. 63 divided by 7 is 9, plus 3 is 12. So 13 is also not correct. Correct? So 13 is also not correct. So we have two wrong outputs in this case, right? And that is how you can check the output, right? So check the data and identify incorrect output or outputs, right? So there are more than one which are incorrect in this case. Question number 5. Now this happens to be a very interesting question. You need to write the pattern rule and then find the 10th term, correct? So I'd like you to work on this and then look into my suggestions. Input 1, output 1, input 2, output 1, input 3, output 2. So what do you see? 1, 1, 2, 3, 5. So what should be this number? Now this is your test question. Think about it. Let me get to this question number 6 also. Question number 6 here is the pattern rule, write the pattern rule and then find the 10th term. So this is your question number 6, okay? So input 1, 2, 3, 4, 5, output says 2, 5, 10 and 17. So I'd like you to copy this question, answer, and also copy question number 5 and then answer and write down your answers. Okay, now here is the solution. Now this is a very interesting series. What you see here is to get the next number, we are adding the previous 2. So if I add 1 and 1, I get 2. Do you see that? And if I add 1 and 2, I get 3. So the rule here is that sum of previous 2 is the next number, right? Do you see that? So likewise, we can get the next number. So 5 plus 3 is 8. So this is going to be 8. And that is how we can complete our series, right? So let me write down that the term number 5, 6, 7, 8, 9, and 10. We need to find the 10th number. How are we going to find it? Well, number 5 is 5. Number 6 is 8. Well, 4 was 3. So we added 3 and 5 to get 8. So 5 plus 8 is 13, correct? Then you add 13 and 8. You can use the calculator. So you add 13 and 8 to get the next number. You get an idea, right? So it is 21, right? And then when you add 21 and 13, so you get 4, and 2 plus 1 is 3. So you get 34. And when you add 34 and 21, 1 plus 4 is 5, and 2 plus 3 is also 5. So you get 55. So the 10th term is 55. Do you see that? That is how you're going to answer this question. The last question here is, write the pattern rule and then find the 10th term. So for 1, the output is 2, for 2 output is 5, for 3 output is 10, for 4 output is 17, and so on. So in this case, the numbers are rising faster than earlier. So when you go from here to here, we have done plus 3, and from here to here it is plus 5, and then it is plus 7. So what you notice here is that it is not constant, right? The second time when you find, then it is plus 2 each time. So that is the kind of pattern which you see. Now use this pattern to find the 6th, 7th and the 10th term. You get an idea, right? So how will you figure this out? Well, you could do like this. To 7, we add 2 to get 9. Do you see that? And then add 9 to 17 to get the 5th term. So when you add 9 to 17, you get 26. Perfect. So the next term, add 2 to 9, so you get 11. And now you add 11 to 26, you get 37. So like this also you can continue. Or you can use a rule. You will notice that these numbers are 1 less than the perfect square, right? 1 less than the perfect square. For example, this number for 2 is 1 more than a perfect square, right? So rule is square of a number plus 1, n square plus 1. So if I do 2 square plus 1, I get 5. 3 square plus 1, I get 10. 4 square is 16, right? So the 10th term should be 10 square plus 1, which is 100 plus 1, or 101, right? So 101 will be our 10th number. But you could do like this also, which is very interesting. So I hope you have learned a lot from this input-output pattern series. Especially the last 2 examples are very difficult questions at this level. I hope you find them interesting and useful. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.